The other day I created a video on how to install a dash node the quick and easy way. And so I want to go through that in a more step-by-step fashion and kind of explain exactly what happened and give you a little bit more detail as to why it was necessary to create the script and what the script does. So this here is the repository for the -d installer script. And like I said, a lot of this applies to Bitcoin and Litecoin and some of the others as well. So if you wanted to just have it done, quick and easy, you copy and paste the script and it goes and installs. I'm going to actually have us look at the script and then go through and explain bit by bit what it's doing. And I'm going to cross-reference that with the blog article that's also here in the repository. So first off, what I'm going to do is create a virtual machine where we can perform the installation. As I go through, I'll talk through it step by step. So I'm going to create a droplet, and I'm actually going to pick the most expensive one, this one with 6 cores and 16 gigs of RAM, because these compile steps take a long time. Like if you're working on a single core, the Bitcoin compile itself takes about 20 minutes. So I'm just going to call this hard dash. And in real time, this will take about 30 seconds or so, and then the IP address that it gives will be usable. So even though the bar completed in about 30 seconds, like I said, I waited another 30 seconds because I found a number of times that when I go to SSH, the device isn't ready yet. The SSH doesn't complete. So here we are. I'm going to hit Command K to clear my screen, and then I'm going to go back to this blog. So the first thing is that, as you saw, I was using Ubuntu, which is a Debian distribution. These instructions and this script have a few parts that are Debian specific. Very, very few parts. Almost all of this is operating system agnostic. But here, this apt is a Debian thing. Basically, this is just system stuff that I'm starting with here. So I'm going to do I'm going to update the repository so it has the latest versions of all the packages. I'm going to skip the upgrade step for time's sake. Or actually, I'll go ahead and do that because that's a good thing to do for security and whatnot. So I'll go ahead and sudo apt-y. In real time, that was about 30 seconds. And now I have the most up-to-date version of the Debian system that's available. Next, I'm going to install just some common developer tools. So what I have here is wget and curl are just things to download over HTTP. Git is for downloading code. Vim is my favorite editor, and screen is something that helps me stay intact when, like if the Wi-Fi goes down or something like that, I can reattach. So from this point forward, I'm going to do screen xrs awesome. So I'm creating basically a virtual terminal called screen that if I need to reattach for some reason, if it's in the middle of some long process, it won't lose my progress. So these are all either operating system utilities that are necessary or tools for the compiler that are necessary. So Build Essential is C and C++ stuff. I believe libtool is as well. AutoTools is. It's for like the AutoMake system. AutoMake. Package config is for package config, which is like AutoMake. libSSL is just the dependencies for the latest cryptographic libraries. libEvent is an old event library that some packages still rely on. BSD main utils, I think that contains stuff like dig and a couple of like really basic commands. And then DH auto recomp, I'm pretty sure, is also part of the auto configuration tools. So that's all normal system stuff. Like if you're on Red Hat or Arch or whatever, all of those things, you just want to use the system version. You don't need to use a custom version. And then this next step here is all libboost stuff. So libboost is like the big, huge, bloated C++ library that contains the common data structures and templates and stuff like that. It's kind of like how when you do any web development, you first have to install like 10 bajillion gigabytes from NPM before you can do your hello world. That's kind of like a lot of C programs are written with libboost, and it's just the big bulky thing that you need for whatever reason. So I'll go ahead and get that installed. I already did screen like I told you that I would. So once all these compile tools are installed, one of the things that's special about these instructions compared with other instructions on Dash, Bitcoin, Litecoin, etc., is that here I'm showing you to put all of the source code and binaries, or I guess it's not really source code as much as like the header files, but the libraries, header files, etc., are all going to be put in /opt-pay, or you might want to call this BitPay or LitePay or whatever. So I think I can just copy and paste. I'm just going to make these directories source, Etsy, var. Var is where the blockchain is going to actually go. Etsy is where the config files are going to go. But the advantage to doing it this way is there's some custom versions that are needed for this because of how old the Bitcoin core is. So it relies on dependencies that may no longer be available in your normal package manager chain for your operating system. So by putting everything into opt-pay, if you need to remove it, it's very easy to start over from scratch without like reinstalling your computer. And these older dependencies aren't going to be in conflict with anything else that you install on your system, like they might be if they were installed directly into /user or in user local. Now, this is important here. In this step, these are a bunch of environment variables telling it where to look for header files and libraries, etc. And this is meant to only be temporary. So once I'm done with this session where I'm compiling, I want to exit out of that terminal. And if I were in a command line only interface, I might want to log out and log back in, because you don't want these hanging around, because if they are hanging around and you go to compile other things, it will mess those up. So this is just meant to be temporary for the terminal session. So I'm going to go ahead and set all those, and they're just, like I said, it's for header files, source files, libraries, that kind of thing. These all define the proper variables. And some of these I found out by trial and error. Like I had to Google and figure out which one to set. Now next, especially if you're in a system that has less than 2 gigs of RAM, you're going to need swap space. So this right here is just to create some temporary swap space, and then we'll turn it off when we're done with the compile. So fallocate makes a 2 gigabyte file. mkswap basically is like mkfs, but it's mkswap instead. Chmod, so that you don't get security error warnings. This makes it root only, not readable, because if you did have RAM that was in swap that might have private keys or something that was readable on your file system, that's a security problem. Not that for the time that what we're doing here that I think it would really matter, but good practice. And then swap on tells the system to actually use it. So I'll just go ahead and paste those in. And some of these commands you can paste the block of them together. Some of them it's better not to. So what I'm going to do is I'm going to go into the source folder. Oh yeah, okay. So in the script, I actually create a temporary place for the source folder, but here in these instructions, I tell you to go ahead and create a source folder. So I'm going to download BerkeleyDB. BerkeleyDB is kind of like the original database. So this is what MySQL was originally built on. And version 4.8 is the one that works well with Bitcore. There are some other versions that work, but you might need special options or certain caveats that come into play, especially if I think if you're using an older data format for like a wallet or something like that, and then you tried to use a different version of the database, like it could become corrupt. So this is just kind of like the standard version for Bitcore, not necessarily the version your operating system would install. And that's why this is being done custom rather than using what's available in the apt or yum, etc. So I've downloaded it, I'm unpackaging it, I'm going to go into that directory. and then I'm going to install it. So the first step is to do configure. This is just common C++ stuff. And I don't remember why I needed to be in the folder build Unix and then run this. I think it's just because when I run make, I need to be in build Unix. Anyway, so I run this configure, and then notice all of these will have this prefix opt-pay. That's something that tells it that this is where it's going to install to. So even though there's all those environment variables, we still need to manually specify -- prefix with all of these. Now I think in real time this one takes about a minute. Oh, did I not go all the way into the directory? I did not. Whoops. Oh, whatever. I'll just... No, I want to do it exactly the way I said, because that's I probably did it that way for some reason, and I don't want to encounter the error of not doing it that way. So I'm going to be in the build Unix directory. I'm going to run configure. This in real time takes something like 30 seconds, I think. And now this make step is going to take about a minute. I'm going to use -J6 to use all 6 cores, and that's why it's not going to take quite so long as it might for you. Then I need to run make install. Is actually going to copy it out of this temporary directories that are here and put it into the opt-pay lib and bin and include directories. And then sudo ld config basically just does kind of a system cache with some of those libraries and updates it with what's in the environment variables and whatnot. I don't remember why exactly I do that, but it's just, I find that running this after a compile and install often fixes problems where you get an error that says that the certain thing can't find the library that it's looking for. And I think I had that problem here, and just putting that in there fixed it. So next is libsodium. So libsodium is a cryptographic library. And again, I think that we're just doing this to use an older version that Bitcoin depends on for compatibility's sake. So same process. We're going to download, we're going to unpack, we're going to configure, we're going to install. So not too much there. And then same thing with ZMQ. We just need this specific version. So for these 3 things, it's not worth the fight of trying to configure your system package manager to make sure you get the right version. It's just a lot simpler to have it custom compiled and installed to opt-pay where it doesn't conflict with anything else, and you know you've got the right version. So I'll just go ahead and run through these steps really quick now that I've explained them. Get out of this directory, do the next one. So I'll get into that directory. Oh, and a lot of people wonder why I use pushd instead of cd, and it's just, if there's 2 tools that do the job and one of them sometimes has problems and the other one always works, I prefer the one that always works. And with when you're writing scripts and stuff, pushd remembers the location that you're in, so you can pop d out of it. So whenever you have instructions, it's so much easier, at least because sometimes you need to go in a directory and then deeper in a directory and then deeper in a directory. And since pushd just keeps track automatically, I prefer to do that and give that in my instructions so that I always know what directory my reader's in, and they're not accidentally getting, mistyping the number of dots, or I don't know. It just, to me, it makes a lot more sense. Keep on forgetting to add the -J6. All right, and now, still need to make install. And this is another one where ld configs seem to do the trick. I forgot to get out of this directory, so I'm going to redo this step.